Hello guys, welcome back to the channel. Today we're gonna learn the basics of chemistry, which are important for class 10, and it also gives overall revision of class 9 chemistry, which are essential topics which will continue in class 10. Okay, so let's start this video without any delay. So these are the topics which you need to memorize in this. Valency chart and chemical formulas will come through thorough practice, but polyatomic ions and periodic table need to buy at them and it should come on your fingertips. Okay, you have to memorize in such a way. So let's start this. And I also gave you the reference of periodic table. You need to just buy at these 20 elements. These are enough for you. And if you observe here one thing, see, protons, the number of protons indicates the atomic number. Remember this sentence, the number of protons indicates the atomic number. If you see, the number of protons here are 1 and atomic number is also 1 of hydrogen. So also atomic number indicates the number of protons. It is vice versa. Okay, so if protons are 3, atomic number is also 3. If protons are 4, atomic number also 4. And in an atom, electrons and protons will be equal. So an atom doesn't contain any charge. Remember this. Next, electronic configuration basics. As you know, I will just draw a diagram for you which will make your understanding more easier. See, if I draw this is first shell, right? Electrons orbit around, revolve around nucleus in this orbits like this, right? So the first shell is K shell, second is L shell, and third is M shell, and fourth is N shell, right? In K shell, maximum 2 electrons can be accommodated, right, or facilitated, and in L shell maximum 8 electrons can be facilitated, and in M shell maximum 8 electrons can be facilitated, and in N shell also maximum 8 electrons can be facilitated, right? Okay, now what is electronic configuration? I've just explained you how the shells are placed in order and each how many electrons can each shell accommodate. What, so I've explained you how each shell is placed in an order, in a sequence, and how many maximum electrons can each shell accommodate. I have explained you this. Now we'll just go a step ahead. So what is electronic configuration? It's how electrons are arranged in an atom's shell. Electrons fill inner shells first, then move to the outer shells. Okay, it means that electrons are, if suppose I gave 10 electrons to this atom, so it arranges first 2 electrons in the inner shell. So arrangement of electrons starts from the inner shell to the outer shell. It goes from inner shell to the outer shell. I've just given a vague example. Okay, I just given this example for your understanding. Okay, next. Now valency. Now see, if you see this carefully, this is a calcium atom, right? In an atom, electrons and protons will be same. Okay, I will just explain how electronic configuration goes with this example. Suppose calcium, the atomic number of calcium atom is 20. Okay, the atomic number of calcium atom is 20, right? So first it accommodates, if atomic number is 20, I've just explained you something in this second slide. Comment please by matching this timeline. Okay, first, if atomic number is 20, then protons will also be 20. Okay, and if protons are also 20, then electrons will also be 20, as it is a calcium atom. It's not an ion. I will explain what is an ion now. If it's 20, what does calcium do? It has 20 electrons. It starts accommodating them from the first shell. What is the first shell? It is K shell. Now K shell has two electrons, right? Can capacitate maximum two electrons, right? So calcium accommodates two electrons in the first shell, right? So we have written 2 in the first shell. Now second, it can accommodate 8 in the second shell, right? We have written 8 here. Now 2 plus 8 10. Now total 12 electrons are remaining. Now it accommodates more 8 electrons in the third shell, right? We have written 8. And in the last shell there is only 2 electrons remaining, because 2 plus 2, so 2 plus 8 10, 10 plus 8 18. Now 2 electrons remain, as the total electrons are 20. These 2 electrons are accommodated in the last shell, okay, in the last shell. But the maximum electrons that a last shell can contain is 2, right? Yeah. So what does this, yeah, I will explain what is table in the next slide. So this is how electronic configuration goes. Remember this. If I take the example of sodium, one second. Is- I just stop this. Yeah, one sec. Yeah. So if I take the example of sodium, which is Na, and its atomic number is 11. So it has total 11 electrons. As protons are 11 in an atom, protons and the number of electrons are equal, right? So its atomic number is 11 and electrons are also 11 electrons. It is represented by E, okay, remember it. Now its electrons are also 11. What does this calcium atom do? Sorry, sodium atom do? I'm just drawing this. This is the nucleus of sodium, or I'm going to just draw Na and circles around it. One, two, and third circle. Okay. Now sodium atom. One second. Now sodium atom. There are 11 electrons. So first, maximum 2 electrons can be capacitated. The arrangement of electrons starts from the inner shell to outer shell. So first, first electrons are arranged in the first shell, and it goes from inner shell to outer shell, right? We have studied. So first it accommodates two electrons in the first shell. Shells are also called as orbits, remember it. So it has accommodated two electrons in the first shell. These yellow dots are electrons, remember it. It accommodated two electrons in the first shell. Now there are more nine electrons. Okay, there are more 9 electrons after accommodating 2 electrons in the first shell. Now it accommodates 8 electrons in the third shell, second shell, which is L shell. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, 8. And it accommodates, now see, now there are only 1 electron remaining. It accommodates the last electron in the last orbit, which is third. For it, the last orbit is third, okay. There are there can be so many orbits, okay. For class 10th, only learning 4 orbits is enough, okay. The problems which come for you is max to max 4 orbits. Last one is calcium, so calcium has only 4 orbits, so it will not pass 4 orbits, okay, for class 10 also and class 9 also. Next, yeah, this is a valency chart. I didn't explain you, sorry, my bad. If you learn the how electronic configuration goes, yeah. Now if you have any doubt based on this topic, please comment. I will be ready for answering you. Now next, what are valency electrons? The electrons present in the last shell. What is a valency shell? For calcium, what is valency electrons? There are two valency electrons. See, these two are valency electrons because they are present in last shell. What is valency shell? The last orbit or shell is called as valency shell. I also told you that orbit and shell are same. It's two names for the same thing. So the last orbit or shell is called valency shell, and valency is the number of electrons which can be shared by an atom. See, I'll explain you this in upcoming slides. Valency chart, quick reference, okay. Yeah, you have to, if you want, you can buy at this, or through the method of electronic configuration you can learn this, okay. Next, why atoms try to become stable? See, atoms try to become stable because they want to satisfy octet rule. And also, yeah, first, this will not be the clear answer for this question. Okay, the clear answer will be this one. They copy noble gases which are already have 8 electrons. So yeah, you have to write both points. Okay, and this is an exceptional point. Okay, exceptional means an exception to these 2 points. Okay, now why atoms try to become stable? Octet rule wants 8 electrons in their outermost shell to be stable. To satisfy octet rule, and they copy noble gases which already have 8 electrons. Suppose if we see in periodic table, calcium is near to argon. Argon. Okay. Yeah, its pronunciation is argon. Argon, right? Now, argon's atomic number is 18 and calcium is 20, right? So calcium is closer to argon. It tries to become like argon, which has already 8 electrons in its outer shell. Means it is following the octet rule. Means it is stable. So calcium also try to become stable by copying it. Okay. This question generally will not come, but it's safe to learn. Okay. Why atoms try to become stable? Or you can also ask how atoms become stable. Yeah, how atoms become stable. How, why atoms become stable, or how atoms become stable. Remove this and this and place how here. How atoms become stable. They become stable by gaining or losing electrons. This is the answer for this question. And why atoms try to become stable is the answer for that question. This is the answer which I'm closing here. I'm gonna do this in red color. Yeah, which will be easier for you to distinguish or differentiate between them. This is this and this is this. Okay, done. How atoms become stable? They become stable by gaining or losing electrons to complete octet. To satisfy octet rule, they gain or lose electrons or share electrons. Okay. Yeah. Next, when an electrons, yeah, I will explain. See. Okay. In this slide only, I will explain. In the last slide only, I will explain. Not this slide. Yeah. In this slide only, I will explain you. See. Valence electrons is the number of you learned. Now, calcium has 2 electrons in its outermost shell. These are the 2 electrons which take place in chemical activities or chemical reactions. Valence electrons are the electrons which take place in the chemical reaction or activity. Remember this, okay? This will be good. Yeah, this is good. Now, valence electrons are the electrons which take place in the chemical reaction. Right now, see, yeah, calcium has 2 electrons in its last shell. Okay, to become stable, it should have only 8 electrons, which it has in third shell. Okay, done. Now, if calcium can gain electrons to become stable, it can gain 6 electrons to become stable. Okay, or it can lose 2 electrons to become stable. Which is easier, gaining 6 or losing 2 is easier? Obviously, losing 2 electrons is easier than gaining 6 electrons. So it loses 2 electrons. Loses 2 electrons and becomes Ca plus, Ca2 plus, because see, the atomic number of the calcium is 20, right? Yeah. Now its protons will also be 20, and these electrons are 20 before losing it. After losing it, electrons became 18. Okay, if electrons became 18 and protons are 20, then positive charge is more compared to negative charge. Okay, so now if 18 electrons neutralize, if 18 electrons and 18 positive charges, electrons are negatively charged in nature, you know, right? Now if two positive charges, the difference between I'm not yeah. So it has 18 electrons after losing. 2 electrons and it has 20 protons, like that only. So now negative charge is less than positive charge, right? Okay, now 18 electrons neutralize only 20 protons, because negative charge and positive charge will be will cancel out each other right here. No, but two positive charges are there which are not neutralized by any other charges, because only 18 electrons are there. There are not 20 electrons to take care of 20 protons. Okay, now these two adds positive charges. These two positive charges add positive charge to calcium atom. So we will write it as Ca2 plus, as two protons are there which are not satisfied by any electron, which are not neutralized by any electron. So Ca2 plus, it is written as Ca2 plus. Done. And if we take the example of chlorine, I'm gonna do it with another color. One second, I will just rub this all so it will be good. Yeah, one distribution. Sorry. My bad. I hope you are understood till calcium, and I'm gonna explain you of a negative charge also. Now see, there is negative charge. Let's take the example of chlorine. Its atomic number is 17 and its electronic configuration is 2 comma 8 comma 1, 8 comma 7, sorry, 2 comma 8 comma 7. Now in its valency shell there are 7 electrons. So to become stable, it needs to have 8 electrons in its valency shell. Okay, now it can lose or gain electrons, right? See, it can lose 7 electrons or gain 1 electron. Gaining one electron is easier than losing 7 electrons. It's obvious, right? It is obvious. Yeah, it is obvious, right? Now it gains 1 electron, so a negative charge is gained. In chlorine, the total protons present are 17 and total electrons before gaining are 17, right? Now it gained 1 electron. It gained 1 electron. So it became 18 electrons here. 18 electrons, right? 18 electrons. Now there are 17 protons and 18 electrons. So negative charges are more here. If negative charges are more, chlorine, one negative charge is more. There are 17 positive charges and 18 negative charges. So one negative charge is more here. So chlorine gets Cl1 minus. You can also write it as Cl minus. Okay, it goes same for magnesium, which becomes as Mg2 plus, and it goes same for aluminium, which becomes as Al3 plus, and it goes same for oxygen, which becomes as O2 minus. There is nothing for carbon and silicon, which, yeah, you're gonna learn about carbon in 10th class only briefly. Yeah, it is a broader topic, I can't explain here. Okay, I will explain about carbon in upcoming videos. Okay, yeah, you can learn these valencies which are mostly used. Okay, these are the elements whose valencies are mostly used. Next, I also explained you why atoms try to become stable. One second, this is all what we say, clumsy. uh, so another thing I didn't explain you is atoms are also stable if they have two electrons. Yeah, it is an exception. If you see hydrogen and helium, yeah, hydrogen and helium is also stable, called stable with two electrons. So hydrogen tries to become like helium because it is nearer noble gas to hydrogen. So every element tries to become like copies the noble gas which is near to them. Okay, same. If you see in this periodic table, if you see in this periodic table, beryllium, lithium, and boron are near to helium. Okay, beryllium, lithium, and boron. Sorry, till beryllium it is near to lithium. Sorry. It's hydrogen, helium, lithium, beryllium. These three are near to helium, right? They try to become like helium. And boron, carbon, nitrogen, oxygen, fluorine. Boron also try to become like hydrogen, and carbon is a different case. So nitrogen, oxygen, and fluorine tries to become like neon. So helium, lithium, beryllium, boron, and hydrogen tries to copies helium, and nitrogen, oxygen, fluorine copies neon. Also, sodium also copies neon, magnesium also copies neon, and aluminium also copies neon. Silicon is also a different case. They share electrons. Carbon and silicon share electrons. Remember this point. And phosphorus, sulfur, chlorine copies argon. Potassium, calcium also copies argon. Okay. Yeah. Silicon is a different case. Yeah. So hydrogen tries to copy its nearer noble gas, which has only two protons, which has only two electrons in its valence shell. Valence shell means it has only one shell, which is the last and first shell. So it is also called as valence shell. It has only two electrons in its valence shell. So helium is also considered stable. So hydrogen tries to become like helium to be stable. Okay, next. This is an exception. You have to remember this. Yeah, I've shown atoms are also stable if they have two electrons in their valence shell. Example helium. Done. Next, common polyatomic ions which you need to remember. You must memorize this. Ions, nothing but ions are, if I say calcium, it is an atom. After losing electrons, it gained charge, positive charge. Thus, it becomes an ion. Ion is nothing but which contains charge. Okay. So calcium 2 plus is an ion. Calcium is not an ion. Remember, calcium is not an ion. And you also know about uh, cation, anion. Cation means ions having positive charge. So calcium is cation. Remember it. Calcium has 2 plus. Calcium cation. Cal. See here in cation, the first word is Ca, which is the symbol of calcium, which is the shorter form of calcium, Ca. Remember like that. Calcium as valence C2. So calcium ion is Ca2 plus. No, it has having positive charge. So cation. Cation. Ca. Remember like that. And anion, I also trick. Anion is negatively charged, right? An means anti. Okay, anti. Anti means something like it is sounding like a negative word, right? Anti. Remember like that. Now, if you see, notice how the ending change pattern. Or notice how the ending changes. 8 and 8 indicates oxygen presence. Remember, 8 and 8 indicates oxygen presence. Okay, means if I take and ide means single element. No, forget this. Okay, forget this. This is not required, and I also this is not correct. Okay, if you take the example of hydroxide, it contains ide and it is OH minus. Okay, forget this only. I'm just cutting off this from here and see 8 and 8 indicates oxygen presence. If you see here nitrate, ammonium. Ammonium is NH4 plus, okay, and nitrate NO2 minus, sulfite SO3 2 minus, sulfite 8. If you are seeing here height, it means 8 and 8. If the suffixes 8 and 8 come, it means oxygen is present in the compound. Okay, and suffix means the last word. Like if you see sulfite, this ite is called suffix, the last word is called suffix. Okay, carbonate 8 is called suffix, like that. 8 and ite indicates compounds. And there is also how to make compounds, right? I will explain this also now. See, suppose if you take Na, sodium, and Cl. Okay, to make compound, what is the charge of Na? What is ion? You have to write in ionic form of the atom, right? To make, because only ions participate in chemical reactions. And in ninth class, there was a question I saw. They gave an element A and said it is A with no charge and A with a charge 2 plus. Okay, they asked which is more reactive. Of course, A2 plus is reactive, and they also can give the question like A is an atom and there is A which is stable, which is the stable form of this, and they asked which is more reactive. Okay, A, this A is not reactive. They have the question is this is A, and this is another A which is the stable form of this, and this green color A is not stable. This green color A is not stable. So now they are asking which is more reactive. Of course, the yellow color A is more reactive because when it tries to become stable, it gains the charge. It gains the charge means it it loses electrons, which gives it positive charge, or it gains electrons, which gives its negative charge. Okay. Now, how are these uh, how compounds are made? Now, I'll explain with an example. Na is Na plus, right? Na1 plus and Cl1 minus. Cl1 minus. There is a trick for it. Remember with the trick only. They two interchange. They two interchange means this charge goes here and this charge goes here. So now NaCl as 1 is uncountable because Na1 and Cl1, that doesn't make any sense. Now if you are writing NaCl and here Na minus Cl plus, you can't write like that. Okay, you have to just take the number, don't take the charge. Suppose if you write Mg 2 plus and Cl also Cl minus, now you have to write MgCl2. They both interchange, right? Oh, I'm just gonna write it here. Mg 2 plus and Cl minus. Now it becomes Mg MgCl2 because this goes here and this charge comes here. No, you should don't take the charge means MgCl2 plus Mg minus Cl2 plus, not like that. You just have to take this number. This is how compounds are made. Okay, you have to remember their ionic form and just interchange their valencies. What is valency? The number of electrons which are shared, right? If I say Mg is 2 plus, okay, Mg loosed it valency electrons. Valency are the last electrons. Okay, now it loosed 2 electrons. These 2 electrons are participating in chemical reaction, right? Yeah, Mg loosed these 2 electrons which are participating in the chemical reaction, and Cl gained 1 electron which gives its negative charge, which is participating in the chemical reaction, right? Yeah, so valence is the number of electrons which participate, which shared between the atoms. Remember this. I hope you have understood. If there is any doubt, ask in the comments. First you need to write in atom, like it's Na and Cl. So what does Na do to become stable? It loses electrons, so it becomes Na1 plus. No, no. So if you want to write, see, Na loses electron, Na1 plus E minus. It loses one electron, right? Yeah, it loses one electron. Now after losing one electron, this electron is taken up by Cl because Cl needs one electron to become stable. So NaCl made a bond here because the electron loosed by Na is gained by Cl. They made a bond here. Same goes for magnesium also. Magnesium gives up 2 electrons, right? But Cl only take up 1 electron. So 2 Cl's means if magnesium gives 2 electrons because it's the atomic number is 12. Now Cl and Cl take 1 electron here. So it becomes MgCl2 because there are 2 Cl, okay? Like that ionic bond is formed, and ionic bond is formed between metals and non-metals only. Okay, metals lose electrons and non-metals gain electrons. Metals are positively charged and non-metals are negatively charged. Remember this. Okay, Next, covalent bonding, sharing of electrons between non-metals. Both atoms benefit. Means if I take the example of chlorine, which is a non-metal, a gas, it is a gas, so it has 7 electron in its valency shell. 7. I'm just using X mark here. If you are seeing this X and X, yeah. Now same here also, X and 2, 6 electrons are here, 6 and here 6. So now this 7, there are 7 electrons. So what does chlorine do? It shares 1 electron with the other chlorine, and the other chlorine also shares 1 electron with the this chlorine. So it shares one electron, so it has gained 1 electron from the other chlorine, and the other chlorine also gained 1 electron, so both are benefited here, and they both become stable here. So like that only, non-metals make covalent bondings between them. Carbon makes millions of bondings same like this only. So I've just given the idea of covalent bonding and ionic bonding. Okay, next, quick tips for success: practice daily, write formulas and equations every day to build muscle memory, use flashcards, make flashcards for important topics which you can revise from in 10 to 15 seconds, and draw. No, it is not required. Third step is not required. And fourth step, understand, don't memorize. It says that understand the concepts deeply and rather than memorizing them, which makes your study interesting and joyful. Next, that's it. Thank you. If you have come till here, it's an honor for me. If you love the session, please like, which motivates to me to make more videos like this. And also, if you have any doubt, comment.